The reason you think LeetCode is so hard and why you're failing your tech interviews is because you're brute forcing LeetCode by solving hundreds of problems without understanding the techniques and patterns behind them. So if you're like most people, you're going to take a random question from the blind 75 and try it for about 20 to 30 minutes before you can't solve it and look at the solutions. You'll copy and paste this to make sure that it runs successfully, and then you'll move on to the next question. The problem with studying like this is that you're brute forcing LeetCode. You're trying to solve hundreds of questions in randomized orders and not understanding the patterns and techniques behind those questions. I've went ahead and identified the top 14 most common LeetCode patterns to solve nearly any question. Now, if you're interested to watch a video on all of these patterns in depth and in animated format, be sure to check out my YouTube video, and I'll have a link to this blog in the comments. The first pattern is the sliding window technique, which is used in order to reduce the time complexity from O of n squared to O of n for searching through strings and arrays. The next pattern is the two-pointer technique, which generally has 2 pointers, I and j, which start at each end of the array, and you slowly bring them closer together depending on some condition. After that, we have the slow and fast pointers, which is very useful to find cycles in linked lists in constant space. Next up, you have linked list reversals, which are useful for reversing a linked list in constant space, but also reversing a specific portion of a linked list. After that, we have binary search, but also modified binary search, where you need to find either the leftmost or rightmost occurrences, but also search in rotated sorted arrays. After that, we have top k elements, where you need to find the top k smallest or largest elements in a list. There are 3 main ways to traverse a binary tree: pre-order, in-order, and post-order traversals, as well as level by level using BFS. All of these are useful to know to solve many LeetCode questions. This also relates to graphs and matrices. In graphs, we have DFS, BFS, and topological sort, and we also have matrix traversals using DFS and BFS as well. These could be tricky to code out, so I have templates for each of these in my blog. Backtracking is effectively recursion. However, you're going to be smart about how you prune paths in order to reduce the search space to be more optimal. Dynamic programming helps, where you can reduce your main problem into subproblems and use those subproblems in order to generate the global result. Bit manipulation is extremely good to know when you need to add numbers without using addition or subtraction, or when you need to count the number of 0 or 1 bits inside of a number. Overlapping intervals is used when you need to merge or consolidate ranges based on the description of your problem. The monotonic stack is extremely useful when you need to find the next greater or next smaller element for all elements in an array. And finally, we have the prefix sum, where you need to query subarray sums frequently across multiple ranges in constant time. I also have an entire YouTube playlist on the blind 75 with every single solution in animated format.